Okay, I just want to use the relationship between the speed of sound on a string and a few variables here to solve a simple problem. So let's say we have a string that's 2.5 meters long. That will be the length of the string. It's under a force of tension of 400 newtons. And the speed of sound on that string is going to be 380 meters per second. The question is, what is the mass of the spring? So we're going to do this in two parts. First of all, we're going to use the speed and the force of tension to come up with the linear density. And then once we have the linear density, we'll be able to solve for mass directly. The speed is equal to the square root of the force of tension divided by the linear density. We have a speed of 380 meters per second, a force of tension of, 400 newtons divided by the linear density. To get rid of the square root, I'm going to square both sides. So this is 144,400 meters squared per second squared. Oh, I got rid of my square root, sorry, ignore that. 400 newtons divided by the linear density. And then I'm going to bring the linear density up to the left-hand side and bring the 144,000 down to the other side. Just wrote out what the units for the newtons are so that I can see how the units cancel out here. Obviously I have per second squared on the top and bottom. I have 1 meter and a meter squared here, so I'll get rid of that. And I'm going to get 400 divided by the answer, 0.00277 kilograms per meter. So that's the linear density of my string. Now I can go back up and use the definition of linear density, that it's the mass per unit length, to come up with what the overall mass for the string must be. Remember, recall the string was 2.5 meters long. So, multiplying both sides by that 2.5 meters, I get a total mass for the string, which is 6.93 times 10 to the negative 3 kilograms, or 6.93 grams. So that's how that works out into some typical numbers.